Welcome to The Explainer. Today, we're pulling back the curtain on the hidden tech that keeps our biggest buildings from, well, melting.
Okay, so let's just think about this for a second. How on earth do you cool something 1,000,000 square feet in size? I mean, you're not just going to stick a window AC unit in a skyscraper, right? Or in an airport or a massive data center. So, what's the secret?
Well, the answer is this really powerful and honestly kind of elegant solution called a chilled water system. And here's the fundamental secret, the big idea. It's not really about creating cold. It's about moving heat, getting it from inside where you don't want it to outside where you don't care about it.
See, trying to cool all the air in a huge building at once, that's just crazy inefficient. So these systems use a much smarter tool for the job: water. You can think of water as this amazing heat sponge. It is fantastic at soaking up a ton of warmth from the air, and once it's got that heat, you can just pump it right outside. Okay, so the best way to picture this whole thing, think of it like a circulatory system for the building. You've got the chiller unit. That's the heart of the whole operation. The pumps, they're the muscle, pushing everything around. The piping network is just like the arteries and veins. And then you have these things called air handling units, which are basically just big boxes with fans that blow the building's warm air over cold pipes. That's how the cool gets delivered to every room.
All right, so let's zoom in on the chiller itself, the heart of the system. This is where the real magic, or well, the real physics actually happens.
Now, this whole thing works because of a secret ingredient, a special fluid called a refrigerant. What's so special about it? Well, unlike water, this stuff is designed to boil at a super low temperature. And that right there is the key. Because when a liquid turns into a gas, evaporation, it just sucks up a massive amount of heat from everything around it. So what this does is create this continuous heat-pulling cycle inside the chiller. It's kind of like a four-step dance. First, you have evaporation. The super cold liquid refrigerant flows past the building's water, and it's so cold it literally boils, turning into a gas and absorbing all that heat. Step 2, compression. A compressor then squeezes that gas, cramming all that heat into a tiny space, which makes it incredibly hot. Then comes step 3, condensation. This super hot gas now releases its heat to the outside air, cools down, and turns right back into a liquid. And finally, step 4, expansion. That liquid gets shot through a tiny valve, the pressure plummets, and it becomes intensely cold, ready to start the whole cycle all over again. It's just a brilliant, continuous loop.
Okay, so that's the magic happening inside the chiller. Now let's zoom back out and see how this heart connects to the rest of the building using that network of pipes we talked about.
So the chiller's one and only job is to get a constant stream of water really cold. We're talking down to a target temperature of around a brisk 6 degrees Celsius. That's about 43 Fahrenheit. So now you've got this ice-cold water, and it's ready to go on its mission, hunt down and collect heat. And this is what we call the chilled water loop. So that fresh 6-degree water gets pumped out from the chiller through a whole bunch of insulated pipes. It travels all over the building to those air handling units. Inside those units, warm air from the rooms gets blown across coils filled with this super cold water. The air gets nice and cool, and in the process, the water does its job. It absorbs the heat, warming up to maybe 12 degrees Celsius. This warmer water then makes the trip all the way back to the chiller to drop off its heat, get chilled down again, and head back out. It's a non-stop cycle, 24/7. Now, as you can probably guess, not all of these systems are built the same. And since they're such complex machines, they need a lot of TLC to keep them running efficiently and, not breaking down.
Really, the biggest difference between chiller types comes down to one thing. How do they get rid of all that heat they've collected? On one hand, you have air-cooled chillers. They're kind of like your home AC unit on steroids. They just use massive fans to blow the heat directly into the air. Simple, cheaper up front. On the other hand, you've got the heavy hitters, water-cooled chillers. These guys use a whole separate second water loop and a cooling tower. You've probably seen those big steamy things on top of buildings to get rid of heat through evaporation. They are way more efficient, especially when it's hot out, but they're also a lot more complex. It's that classic engineering trade-off, right? Cost versus long-term performance.
And let me tell you, this is definitely not a set it and forget it kind of deal. Keeping these systems healthy is absolutely critical. You're constantly monitoring water quality to stop pipes from literally dissolving from corrosion. You're hunting for tiny leaks. You're logging all the performance data to spot trouble before it starts. And just keeping everything clean. If you slack off on this stuff, you're not just wasting a ton of energy and money, you're risking a complete catastrophic failure. And nobody wants that.
So yeah, designing and managing these systems, it's a huge business. This isn't some niche tech, it's the backbone of modern climate control, and it's all engineered by some of the biggest names in the game, firms you've definitely heard of. We're talking about companies like Carrier, Trane, and Daikin. These are the giants that build these absolutely essential machines.
So think about this. The next time you walk into a perfectly cool airport on a hot day, or a comfortable office building, or even when you're just scrolling on your phone, remember that your phone is connecting to servers in a data center that has to be kept chilled. Just remember the invisible engineering that's making it all possible. Somewhere, behind the walls or up on the roof, there's a chilled water system, just tirelessly moving heat around, making our modern, comfortable world work.
It really makes you wonder, doesn't it? What other amazing, hidden systems are out there, working silently in the background, just keeping our world running?